So you probably HDMI.
I can do that.
And lapel mic. So let's give a round of applause for Andrew McGarry from octoScope.
Got it. Cool. I think so. Thank you, everybody. Thank you for the intro, Alex. My name is Andrew McGarry. I'm here today with our president and CEO, Fanny Mlynarski, as well as Nandini Venkatraman. And so we're here, of course, representing octoScope. What does octoScope do? We build, design, and manufacture personal wireless test beds, for testing wireless devices. We have a demo later on today of one of our systems, but I want to introduce a couple of the modules that we use when we construct our test beds, as well as give you an introduction into how we think about wireless testing. So in general, there are kind of three types of wireless testing done in industry, right? So there's testing that's done for marketing purposes. Where a device is made to perform at its maximum possible levels, right? Maximize throughput, maximize range, right? There's also engineering testing, right? So that would be your design verification testing, right? So does your device conform to certain standards, right? Does it do all of its diagnostic outputs make sense? So those two kinds of testing are usually done in a very controlled, very contrived environment. So then, when you take your device and you put it out in the real world, now all of a sudden it's, coming into contact with many different types of impairments, right? Non-ideal conditions. And they all overlap with one another, all of these conditions. So teasing apart exactly which of these conditions is affecting your results, right? Maybe causing an undesired behavior is very difficult to, tease apart. So most wireless systems are affected by the same kind of environmental variables, such as path loss, or multipath effects. Maybe if you're designing a mobile phone and you want the Wi-Fi system on it to work while your user is running around with it, right? Motion might be a factor as well. And then of course all of these systems. Is it? Sorry, testing. How about that? Testing. 1, 2, 3. Better? Thank you. Again, of course, all wireless systems deal with interference on some level, right? So, if your neighbor is, streaming video traffic to, their set-top box at home, how does your device perform when it's asked to compete, against that, very aggressive type of traffic? We've listed a couple of common, tests for wireless devices on the right hand here. And in the middle, we have a lot of the variables, which can affect the outcomes of these tests. So the purpose of this slide is really just to demonstrate the fact that if you want to be very thorough, right, and methodically run every single test against every single variable, right, then the number of test cases that you have to run just explodes, right? There's a ton of them. So how do we overcome just the sheer volume of testing, right? You need to undergo to make sure that that you've tested your device thoroughly. All right. So we've designed, to combat the rising number of test cases, the Octavebox personal test bed. Oh, excuse me. Here we go. So we build these test beds with the goal of automating a lot of these common wireless tests. We build these test beds from a number of building blocks. So, our signature Octavebox semi-anechoic shield environment, as well as a number of programmable modules, right, such as our PAL unit, our wireless partner device, our programmable attenuator unit, the Quad 10, as well as our interference generator, right, the iGen. So by combining these elements together, what we can do is we can automate a lot of these, common test cases, but then also importantly, right, introduce some of these common types of of interference and impairments into the test environment, right? So we can add multipath, in programmatically during the course of tests, as well as certain types of interference like Wi-Fi, Bluetooth waveforms, Zigbee. Also, by using our programmable attenuators, what we can do is we can force certain adaptive behaviors, right, to occur, right? So we can change our environment so that a roaming event will happen. So a quick example of how you could run a test and quickly gain insights as to how your device adapts is this kind of example, right? So in Wi-Fi devices use these things called modulation coding schemes, right? These are standardized sets of modulation schemes and forward error correction codes. And so what we expect a Wi-Fi device to do is to move from using maximizing bit rate when path loss is low, right, to maximizing the robustness of communication, right, at very low MCS levels when path loss is high, right. So ideally, we want our Wi-Fi devices to follow right along the very edge of this curve, right. They want to maximize bit rate for a given attenuation level. But of course, it's not always the same, right. So if you automate a test where you can very quickly change the path loss of the environment, what you can do is you can measure throughput across the range of these attenuations and watch to see if your device adapts appropriately. So like in this example, this device may have held on to MCS 9 or 8 a little bit too long before the bit rate started to plunge. So these are the kind of insights that you can get very quickly by automating a lot of these test cases. So we talked about the first and third points in here, but I also want to talk about how the Octavebox provides an ideal environment if you want to test some of the latest and greatest technologies in wireless communications. All right, so if you're interested in doing testing with MIMO, right, and its component technology beamforming, or you're going to be testing with 11AX, right, the new version of Wi-Fi. So we've proven that our Octavebox provides an ideal MIMO environment. And can demonstrate some of the highest bit rates achievable in 11AC. So we're excited to see its performance in 11AX as well. So the primary benefit that we see for these test systems, right, for the SDR community is the ability to rapidly iterate on testing. So the less time you have to spend on teasing apart exactly what impairment might be causing an undesired behavior in your test outcomes, the more time you can spend modifying the waveform itself and programming. So by automating a lot of these test cases, you can go back to just working on the waveform itself. So I'm going to introduce a couple of the modules that we use when we are building our test systems, right? So this is our PAL. So it's our wireless partner device. So this device can act as a Wi-Fi access point or a Wi-Fi station. It has traffic replay capabilities, right? So you can load it up with a PCAP file that you captured previously and replay the traffic in it. And you can also use it to capture, Wi-Fi traffic and save it into PCAP format for later review. So our current generation of PAL is 4x4 capable, right? It's a Wave 2 device, if you're familiar with that term from 11AC. Also can transmit up to 160 megahertz wide channels. So our future versions of the PAL are going to be implementing a Wi-Fi 11AX as well. So our next version is going to be an 8-stream device, and also include a Bluetooth radio. So we also have a Multipath Emulator that implements a fixed channel model. So this is IEEE 802.11 Model B, right? So it mimics the environment of a home, right, of a small home, right? So if you want to test in a controlled environment, but have a happy medium between that and testing in the real world, right? So the MPE allows you to simulate the effects from reflections, right? And fading effects at the receiver that result from that, and programmatically swap in that affect, over the course of, our automated testing. So our MP has the ability to swap in that multipath element, as well as help you test in like non-line of sight conditions, right, where you bypass the element. And you can swap between them in the middle of a test. Also includes a programmable attenuator if you're doing something like a rate versus range test. So the glue that holds all of our test beds together is the Octavebox software suite. So here's an example of what the user interface looks like for this, right? So on the left-hand side of the screen is where you can plug in which of our modules you have in your test bed, and it's where you set up your test, right? You can save this configuration, right? Change between a number of different types of tests. Then on the right-hand side, we display live data, from these, while the test is running. So we have, throughput information from a number of different traffic endpoints displayed here, for example, as well as a polar plot showing throughput performance versus orientation. What we can also do is incorporate statistical information from our PAL unit, right? So our PAL unit has the ability in its monitor mode to record signal strength information as well as the channel bandwidth of a Wi-Fi transmission or the MCS scheme that it's transmitted at. So we can include all of that in our plots, and then this can be saved and reviewed later. So just to, what I want to emphasize with this slide is that octoScope is present throughout the wireless testing ecosystem, right? So all the way from operators up to the chipset vendors, right? These companies trust us to provide environments that have show repeatable and stable results. So we're also involved, specifically at the Wi-Fi Alliance. So we're there. We're going to be there, in the coming weeks for the 11AX Plug Fest, right? Helping companies to demonstrate, their new AX chipsets. And our testbed solution has also been recommended as part of their standardized testbed for demonstrating coexistence between Wi-Fi and LTE. So it just gives you an example of just how trusted a name we are. So we offer a range of standard configurations for our testbeds. So this is just a couple examples of them. So our demo later today is going to use our stack benchtop. We're going to be running this demo remotely. But I want to emphasize that we have different test configurations that help to address different needs in wireless testing. So if you'd like to talk with us about your needs, right, and come and explore our solutions, or just come by and visit the office, right? We're right over in Littleton. And we'd be happy to see you there. Yeah, so thank you. Thank you.
Well done.
Thank you.